Okay, orthogonal coordinate system. So before this, we study about just x and y. So now orthogonal. Orthogonal means that we have 3D coordinate system. So there are three types of orthogonal coordinate system: Cartesian, cylindrical, and also spherical. So actually in 3D, okay, the shape all the shape is come from three basic shape. Wait, three basic shape. Sorry. Okay. This one is from cube, cylindrical, and third one is spherical. Spherical circle. Okay, spherical. Actually, all the 3D shape is come from these three basic fundamental. Okay, so and now today we will study about the orthogonal coordinate system. So first, Cartesian system, coordinate system. So why coordinate system? A coordinate system is used to specify the position of a point in space. So we have 3D, X, Y, and Z. So 3D. Okay, let's say we have one point P. Okay, P is equal to coordinate Y. X is equal to okay. Let's draw first X, Y, and Z. X. For example, our coordinate for P as one P we call, let's say, 2x, and coordinate Y is, for example, 3y. So the location of the P is points one, this one here, and then we have one more as this. For example, Z axis, let's say 4 Z. So the P point is be here. Okay, P. For 3D, P is equal to X2, Y3, and 4. Okay, 2, 3, 4. The position of the P. Okay, this one is for coordinates, Cartesian coordinate. Okay. Cartesian coordinate, they have X, Y, and Z. X, Y, and Z. X, Y, and Z. Okay, 3D. Okay, for unit vector is X hat. X hat means that the coordinate for along direction, X direction, this direction, X hat, Y direction, Y hat, and Z direction is Z hat. So in this case, okay, in our case, coordinate for P is equal to, vector for P is equal to 2x plus 3y plus 4z. Okay, this one is Cartesian coordinate. So in terms of x, y, and z. Okay, we have length, depth, and also height. So we can draw cube. Length, this one is y axis, this one is x axis, this one is z axis. So we have length, height, and also our width. Okay, this is Cartesian coordinate. Okay, any question? No question. We go to the next coordinate system we call cylindrical. Okay, cylindrical coordinate system. Okay, let's say we have x-axis, y-axis, and also z-axis. Okay, this point we can represent as we can represent in a Cartesian coordinate. So if you use Cartesian coordinate, we just use this method. We have width, length, this width, length, and also height, x, y, z. So if we represent that coordinate with cylindrical coordinate, r. Okay, if we plot this, this is also r, sorry, r, parallel r, this one r, and also we have angle here, because we draw a quarter cylinder. When we plot quarter cylinder, a cylinder like this, cylinder. So we just plot quarter only between x-axis and y-axis. So just a quarter. So quarter. Okay. Okay, quarter. Okay, like this. Point P. So we also can present this point using cylinder coordinate. So for cylinder coordinate, they have r. R is distance between z-axis and number P, point P. R is distance from z-axis to point P, okay, to this point P. And also we have angle here. Angle here, we call phi or phi. That angle is between from x-axis to r, to radius. Angle from x-axis to r. Okay, this angle, this r, this angle, phi. And also we have z. Z is distance from xy plane, or we can say our height, the height of the cylinder. So this height cylinder height. This is z, point z. Okay, z. This one is 0, x, y axis, so 0 point here. This one is z, point at height of the cylinder. Okay. So the variable for coordinate, cylinder coordinate is r, phi, and z. So r, phi, and z. This is the variable for cylinder. For Cartesian, we have x, y, and z. Okay. Phi is the angle from x-axis to our radius, r. Okay. Okay, next is the example. Example 2.1. Okay, which one is the possible cylinder coordinate of point P? So let's say we have point P here, point P there, y, x, z axis. So point P is here, this P. So length is 3. 3 means that the height of the P is 3. Z is 3. Okay, it's 3. And also the distance from this point to this point we call R. 4. So R is 4. Z equal to 3. This 3. And also angle is from phi is angle from x-axis to that point. So angle is here. So angle equal to pi. So the answer will be B. 4R pi phi and also Z equal to 3. Okay, next is the point is P here. The height is 2. Height is 2. So this one is minus 2. Distance from this point to Z axis is 4. So R equal to 4. And also angle is phi is equal to the angle from x-axis, this is x-axis, until that point, okay, 3/2 pi. Okay, for this is equal to 270 degree. So it means that the answer will be C. Okay, any question regarding the point of P? No question. We go to coordinate system. We go to unit vector. Unit vector for cylinder is R hat. R hat, phi hat, Z hat. Hat and hat. Hat. This is hat. We call hat. This is for unit vector. So R is the direction of radius. So this is the radius. Direction of radius. Is of radius. This is R. So direction is from z-axis to this point. Direction will be like this. Direction of R, vector R. R, phi, and also Z. Direction of phi is from, we know that phi is the angle from x-axis to R. So this is the direction of phi. And also finally Z. Z is height of the cylinder. So the direction of Z is from here, Z, go up, direction of Z hat. Okay? Direction of Z is from 0 xy axis, go follow direction of Z. Direction of R is from, we know the definition of R is equal to, okay, perpendicular distance from Z axis. Okay, the definition of R, radius of the cylinder, this radius. Direction of R is from Z axis to point P. Okay, so range is 0 to infinity. And angle is angle from positive x axis, so means that the direction of angle is from x-axis direction here, from here. Okay. So means that for point P, so for this point, we can plot the direction. Let's say this point. At this point, direction of R is here. Okay, just follow direction of R. Direction of phi will be here. Phi. This one is R. Direction of Z will be go up. Z. Okay. Okay, at this point, direction of R here, this is R. So direction of R will be here, R hat. Direction of phi from x-axis, direction of phi is here. And direction of Z will be go up. Okay? Okay, at this point. Okay, direction of R, this R. Okay, here, direction of R. Direction of R, phi will be into. Okay. Into. Sorry, into. This one. Direction of R here. Direction of phi go inside the board, and also direction of Z is go up. Okay, all 90%. Oh, sorry, 90 degree perpendicular each other. 90 degree perpendicular. Okay, that one is direction. Direction of vector R, direction of vector phi, and also direction of vector Z at that point. Okay. Then now is example. Unit vector point at point P. So at this point. So direction of R will be just follow this radius. So R will be go there. Direction of angle, direction of phi, this one's R. Direction of phi, we know that phi is angle from X, so it will be like this. Here. Okay. And direction of Z will be go up 90 degree Z. Okay, answer is C. Okay, the next example is P. Point P is here. So where's the direction of R? Okay, we know that R is from Z axis. Direction of R is from Z axis. So from the axis it will be here, and R will be toward this one. Direction of phi will be from X axis. So here, X axis from here. Phi. Okay. Direction of Z will be go up. Z. So A. So any question on the position and also direction vector of the cylindrical coordinate system? Okay. No question. Oh, very good. So this one is unit vector, sorry, unit direction, r times phi equal to z equal to, okay, r phi z. So r phi z. We can write r phi z, r phi z, r phi z, r phi z. Okay, r times phi equal to z. Phi times z equal to r. Z times r equal to phi. Phi times z equal to r. Z times r equal to phi. Okay, this one. Okay, if we reverse it, we will come minus. R, sorry. Okay, R times Z equal to phi, equal to minus phi. This one is minus phi. Z times phi equal to minus R. Phi minus phi times R equal to minus Z. R times Z equal to minus phi. Okay, this is how we draw. From this one, we can draw the as is x, r, phi, and z as is. Okay. Okay, next is coordinate transformation. So we have Cartesian and also cylindrical. So we can transform. We can transform the coordinate from Cartesian to cylindrical, or cylindrical to Cartesian. Okay, this is how we want to specify the coordinate of point P. Show the relationship between this one, we can transform to cylinder, or cylinder we can transform to Cartesian. Z, X, Y, Z. Point P, this is our R. This is angle, phi. First we plot quarter cylinder. So quarter cylinder, this is our R. This is point P. Okay, location for point P is P, R, phi, and Z. This one is when we use cylinder coordinate, R, phi, and Z. If we use Cartesian coordinate, X, Y, and Z. Look from here. Our eyes is here. Let's say this. Okay, we look from here. What we can see is X, Y as this. Y and X, sorry, X as this. This as this X, this as this Y. We look, and this one is R. R, this R. We have phi here. Here. X equal to R cos theta, cos phi. Okay. This X. This length. Okay, we have here phi. This one is X. This one is R. So this is equal to R cos phi. Okay, that X. Y will be equal to R sin phi. R. This one y axis. This one is, sorry, x axis. This one is phi. X. This one is coordinate y. Okay, x is equal to r cos phi. Y equal to r sin phi. Cylindrical r phi and z as Cartesian x, y, and z. So x will be equal to r cos phi, y equal to r sin phi, z equal to z. Example, example x coordinate, okay, Cartesian coordinate, given Cartesian coordinate x equal to let's say 1, y equal to 1, yeah, z equal to 2. Okay, now convert from Cartesian to cylinder. Cartesian to cylinder. Okay. 1 x, y, 1 z equal to 2 here. So this point is x, y, z, 1, 1, 2. Now convert to cylinder. We know that for cylinder, R equal to, oh sorry, this one is from okay, again, so that one is from cylinder to Cartesian. So now from Cartesian to cylinder. From Cartesian to cylinder, let's say we have x here, we have y here. So this one is r. R will be equal to, we know we have theta here, sorry, phi here. R will be equal to square root x square plus y square. Okay, R this magnitude will be equal to this axis square, this is square. Yeah, this is R, this is x, this is y. R equal to x square plus y square. Theorem Pythagoras. Okay, this is R. Next is the phi. What is phi? Phi will be equal to, we know that this one is x, this one is y. So tangent inverse y over x. Okay, and z equal to z. We can find our coordinate. R equal to x cos 2 x square 1 square plus 1 square equal to square root 2. And then z equal to 2. Phi equal to tangent y over x. Tangent y is equal to 1, x equal to 1. So tangent 1 equal to 45 degree. So square root 2, 45 degree, and z is 2. Okay, this one is in form of cylindrical, and this one is Cartesian. Okay. Okay, good. So this point we can represent using Cartesian coordinate, x, y, z, and also this point also can represent as cylindrical coordinate. For cylindrical coordinate, we have r, phi, and z. Okay, this one is transformation from cylindrical to Cartesian. So, any question regarding cylindrical and also Cartesian? Cylindrical coordinate system and Cartesian coordinate system, and also transformation from cylindrical to Cartesian and Cartesian to cylindrical. So, any question?